You know that plastic bottle in your hand or the high-tech fabric in your jacket? Maybe even the tires on your car. They all seem pretty straightforward, right? But behind these everyday things, there's this hidden world of molecular engineering. It's a story of life, death, and just incredible innovation. So today, let's unlock the surprising science of polymers. First things first, understanding the materials that build our world, this isn't just some boring textbook exercise. As we're about to see, getting it right can save lives. And getting it wrong, well, that can lead to absolute catastrophe.
To really wrap our heads around the stakes, let's start with a disaster that didn't just shock the world, but it changed materials science forever.
Picture this, January 28th, 1986. The Space Shuttle Challenger lifts off. And then, just 73 seconds later, tragedy. The investigation would eventually uncover a fatal flaw, not in some grand, complex system, but in a tiny, almost overlooked component. So what was the critical point? The whole disaster came down to a simple O-ring made of silicone rubber. On that freezing cold launch day, the material lost its flexibility. It became rigid, it failed to seal properly, and it allowed super hot gases to escape from a rocket booster. That led to catastrophic failure. It's a chilling reminder that a material's properties can change, and change dramatically with the conditions. But the story of materials is also a story of incredible solutions. I mean, take the Concorde crash in 2000. It was caused when a burst tire threw debris up into a fuel tank. The fix wasn't more metal, it was a high-performance polymer. They reinforced the undercarriage with Kevlar, yep, the same stuff used in body armor, and created a life-saving solution. So you have these two stories, one of failure, one of salvation, and they both point to the same hero, a class of materials that has really quietly defined our modern age. So let's pull back the curtain and uncover the secret of polymers. So what is a polymer exactly? Well, at its core, it's just a huge molecule made of smaller, repeating units called monomers. The easiest way to think about it? Imagine linking thousands of paper clips into one super long chain. That's the basic idea. These long chains, all tangled up like microscopic spaghetti, are what give polymers their totally unique and versatile properties. And this quote just brilliantly illustrates the revolution they've caused. I mean, it really wasn't that long ago that our material options were pretty limited: metal, wood, stone. But today, polymer science has given engineers this incredible library of materials to choose from, each one with properties you can tune for almost any application you can dream up. The creation process itself, which is called polymerization, is actually pretty simple in concept. You start with a batch of these single molecules, the monomers. Then, a chemical reaction kicks in and acts like a zipper, linking them together one by one into a long, really durable chain. This process is the key to creating everything from a simple plastic bag to a bulletproof vest. What's so incredible is how this simple chain-making process has allowed polymers to completely transform our world, replacing older, traditional materials in pretty much every field you can imagine. I mean, the examples are literally everywhere. Old cast iron gas pipes are being swapped out for flexible, corrosion-resistant polyethylene. The massive steel cables holding up suspension bridges, they could soon be replaced by carbon fiber, which is way lighter and stronger. And honestly, some technologies like car airbags or flexible blood bags, they just wouldn't even exist without polymers. Let's just focus on one of those examples for a second, because the numbers here, they are just staggering. Okay, so think about deep-sea oil rigs. They're tethered to the seabed with these massive ropes. Now, if you use steel, you eventually reach a depth where the steel rope can't even support its own weight. But if you replace it with carbon fiber rope, which is 5 times lighter for the same strength, suddenly you can drill in waters that are twice as deep. This one material innovation has completely transformed the world's energy scene. And the impact is truly all around us. That 120-mile-per-hour tennis serve, it's powered by a polymer composite racket. Firefighters walking through flames are protected by heat-resistant polymer fabrics. In medicine, we have stitches that just dissolve on their own and artificial joints that can last a lifetime. And the lighter polymer parts in cars and planes are saving billions with a B in fuel costs. All right, so we get it. These materials are incredible. But how do we actually go from a raw polymer powder to a finished product with the exact properties we need? Well, it's kind of like cooking. You don't just use flour, right? You add yeast, salt, sugar, With polymers, we use additives. Modifiers can change the material's color or how it handles an impact. Stabilizers protect it from breaking down in the heat or sunlight, and processing aids just make it easier to shape and mold. By mixing these spices, you can create thousands of different recipes from the very same base polymer. And once you have your recipe, you've got to shape it. A really common method is called blown film extrusion, used for things like plastic bags. Melted plastic gets pushed through a circular die to form a tube. Then air is blown into the tube, inflating it like a super long bubble. This bubble is then cooled, collapsed, and rolled up. Simple, efficient, and it's happening on a massive scale all around us. We've seen how polymers have shaped our modern world, solving countless engineering challenges. But what about the challenges of the future? Now, this is fascinating. When you think of plastic, you probably think of oil. But scientists are now using genetic engineering to actually grow biodegradable plastics inside plants like sugar beets. It completely changes our perception of where plastics come from, and, it opens the door to a truly sustainable future. And that sustainability piece, that's the crucial point. The incredible durability that makes polymers so useful, well, it also creates a huge environmental challenge. The next great frontier for material science is designing products not just for performance, but for their entire life cycle, making them easy to recover, reuse, and recycle. Which leaves us with this final, pretty thought-provoking question. These remarkable long-chain molecules gave us the tools to build a faster, stronger, and safer world. So can that same ingenuity now be turned to create a cleaner and more sustainable one? The science is ready. The challenge is ours.